All right, section 10.2, finding arc measures. So got some new terms here. So if you look at this, we have a circle with a center C. And then we have an angle here, ACB. That's an angle. And the angle measures 50 degrees. Well, that is called a central angle because the vertex is the center of the circle. So it's called a central angle. So if you think about it, whenever you have a pizza or a pie and you cut it into a bunch of pieces, all of those angles around that pizza or the pie, those are all central angles because their vertex is at the center of the circle. Now it says the measure of a minor arc is the measure of its central angle. The expression measure of AB, that's what this means. The measure of arc AB. This is the arc symbol up here. And an arc is just this right here. Let's do a different color. This. If you think about it as the crust, okay? So you have a piece of pizza and the crust is right here. That crust is the arc, all right? So the measure of arc AB is also the same as the central angle. The measure of the entire circle is 360. We know there's 360 in a circle. The measure of a major arc is the difference of 360 and the measure of the related minor arc. A semicircle, which makes sense, is half the circle, is 180. So I will add this. The measure of a minor arc is less than 180, and the major arc is greater than 180. All right? So you have a minor arc, semicircle, major arc. Okay? Example 1. Find the measure of each arc of circle P, where RT is a diameter. Okay? Well, if RT is a diameter, that means this arc right here is a semicircle. So that makes RT right there, right, 180 degrees. Which means that this is also 180 degrees. So, if we look at it, RST, if you read as you go through, here's R, you pass S, you have T, that's 180 degrees right there. Okay, so let's get that. That one's the easy one out of the way. Now, you look at B and C and they're like RTS, RST. What does that mean? Well, we'll talk about that in a second. Now, if this is 180 in the green and this piece right here is 110, that leaves 70 degrees right there. Because 70 plus 110 is 180. Okay, so we have 180, 110, and 70. Those are our three numbers basically. Now, when this one here says RTS, get a different color here. We start at R, we go past T and end at S. So basically we're doing 180 plus that 70, which is 250 degrees. RS is just from here to here. And we know that's 110 degrees because it's labeled. Okay, moving on. Again, if it's going too fast, hit pause, rewind, whatever you need to do. The arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. Kind of one of those things that's just kind of like duh. So ABC, so from A to B to C, is made up of AB and BC. Kind of one of those common sense rules, really. All right, so find the measure of each arc. GE. Now, here's another thing you got to realize. GE, which way do we go? Do we go this way or do we go this way? Okay. If it's a minor arc, we use two letters. So this is going to be minor. And if it's got three letters, It's a major arc. Okay, now technically I could call this GHE, but we don't do that because we just use two letters. So when I say GE, that means I'm going from here to here. So that's 40 plus 80, which is 120. Okay. GEF. Well, I start at G, I go towards E, and end up at F. So there I'm adding 40 plus 80 plus 110. So that's 230 degrees. Okay? So you just go in order. And then GF, well, GF is simply right here. Well, there's no number there. Well, the green major arc, 230, plus GF make a whole circle. So 360 minus 230 is 130 degrees. So this is 130 right there. If you add up all those numbers, they add up to 360. Okay? Example 3. A recent survey asked teenagers whether they would rather meet a famous musician, athlete, actor, inventor, or other person. The circle graph shows the results. Find the indicated arc measures. So, AC. Well, we have a choice, left or right. Well, since it's only two letters, it's a minor arc. And think about it. I'm going to erase this so you don't have to write this. If I went this way to C, that's more than halfway. That is a major arc. So I'm going to go this way, and that means I'm adding 108 and 29. 108 plus 29, and that's 137. ACD. So I'm going from A to C to D. So I've already just done AC. Okay, so I'm just going to keep going to D. Now we know what AC is, so we're just going to take that 137 and add 83. That's 220. Right? ADC. Well, that's going the other direction from ACD. So ADC is A to D to C. So we're going to add 79 plus 61 plus 83. All right? And when we do that, we get 223. That's one way we could have done it. But notice, ADC leaves off AC, the other direction. So another way to do that, since you already knew AC was 137, we could have also done 360 minus 137, which would give us 223. So you have two options. It's up to you. EBD. I'm going to erase this. No, not. Try again. There we go. EBD. So I'm starting at E. I'm going towards B, all the way down to D. Well, that's not a lot of numbers to add up, but look what the only section that's missing is this one right here. So I'm just going to do 360 minus 61. Easy to do in our heads. 360 minus 60 would be 300, so one more would be 299 degrees. All right, two new theorems. Congruent circles theorem. Two circles are congruent if and only if they have the same radius. All right? So if two circles have the same radius, then the circles are congruent. Kind of, again, one of those kind of obvious ones, but it is a theorem. Congruent central angles theorem. In the same circle, or in congruent circles, Two minor arcs are congruent if and only if their corresponding central angles are congruent. Well, again, if you know this is 40, then that's 40. And if you have these marked congruent, then everything's 40 and you're good to go. So, example 4. Tell whether the red arcs are congruent. Explain why or why not. All right, well, the red arc here, DC, now green, has a central angle of 80. EF has a central angle of 80, so it's yes. Both central angles are 80 degrees. Or you could just say they have the same central angles, or the congruent central angles theorem, whatever. Okay? B, RS and TU. RS sits inside TU. Okay? TQU and RQS both have the same 90-degree angle marking. Okay? So the answer again is yes. They have the same measure, but the arcs are not congruent. Because circles are not congruent. Or you could say are different size. So they both have 90 degrees as the measure of the arc angle, but the arcs are not congruent. They have a different measure because the circles are different. And C, last one. 95 and 95. So just like A, yes, both central angles are congruent. Or you could say R95, whatever. Good to go. And that is it.